Hi everyone, this is tutorial 6, question 6. And this is a question concerning converting forest into soybean plantation. So we're told some information. We're told that we currently have 1,000 square miles of forest and some of it wants to be transferred into soybean use. So forest knockdown and soybean plantation established. And our goal is to figure out, well, a couple of things, but our main goal is to figure out what's the quantity of square miles, the quantity of land that should be used for soybean plantation. So we're told some information on both soybean and forest use. Let's go to the soybean side first. We're given this bit of information. P equals 18,000 minus 10Q. Now this is a demand function. This is a relationship between price and quantity, and it's a negative relationship, and that's what a demand function is. It's this demand function I've drawn on this graph. But let's lead up to that. There's a couple of bits of information I can sort of figure out from this demand function. I can plug in a quantity and solve it, and it'll give me a price. Or I can do the opposite. I can plug in a price and rearrange some things and it'll give me a quantity. And we're going to do that. First, let's draw it. I've got a price axis here and a quantity axis, and this is the quantity of square miles of what is currently forest. This downward sloping line is the demand curve for soybeans that this equation represents. I've drawn it so that it intersects at a point up here of 18,000. And that's because this value here, the constant in that equation, is where the demand curve intersects the p-axis. So think of it this way. If quantity was zero, so we put that as 0, 10 times 0 is 0, and we're left with just 18,000. And we can do something similar to figure out where the demand curve intersects the quantity axis. I've already got it written here at 1800, but let's figure it out. Instead of setting the Q to 0, now we're going to set the P to 0. And I've done that here. What does that mean on the graph? Well, it means the price axis has a value of 0. In other words, when P is 0, what will Q be? So we set P to 0, and we know that 0 equals 18,000 minus 10Q, or in other words, 10Q has to be 18,000. Well, 18,000 divided by 10 gives us 1800, so Q has to be 1800. Let's test that. 10 times 1800 is 18,000. 18,000 minus 18,000 is 0. Excellent. So, 2 points where they intersect, at 18,000 and at 1800. We've got our demand curve for the use of this forest as soybean plantations. Now let's go over to the forest side of things, up here. We're told two pieces of information. First, we're told that there's a 1 in 200,000 chance that in every square mile we'll find some medicine that's worth $1 billion. So a 1 in 200,000 chance. We need to convert that into a probability, and that's what I've done here. Literally 1 divided by 200,000 gives me, well, that's 5 zeros and a 5 at the end. I multiply that probability by the benefit we would get if we found this medicine, that's $1 billion, and we end up with $5,000. What's that, 5 grand? It is the benefit of every square mile of forest, given that we may find some medicine. The second piece of information we're given is about what the citizens of Brazil are willing to pay to keep this forest as forest. We're told that 1 million citizens are willing to pay 1 cent per square mile each. So if 1 million of them are willing to pay 1 cent, we multiply 1 million by 1 cent, and it gives us $10,000. All of these values I'm talking about are per square mile. So I've now figured out the value per square mile of leaving forest as it is because of medicinal purposes, and the value per square mile of leaving the forest as it is, because people just like forest. So we'll add those two together, and we have a total value of $15,000 per square mile. That's really a benefit though, so I'm going to stop talking about values and refer to it as a benefit. In other words, price equals $15,000. This is the demand curve for leaving the forest as forest. Note that there's no negative or positive factors to it like we had in this demand curve. It's just a flat line, P equals 15,000. And I've drawn that up here. It's a demand function, P equals 15,000, a horizontal line. So now we have the demand curve for the land as soybean plantation and the demand curve for keeping the land as forest. Our goal is to figure out the quantity that we should convert to soybean. Now I've gone and done that here. I've got a quantity here and I've based that upon where these two curves intersect. Let's figure out the logic of this. 0 of this forest has been converted to soybean. Let's see if we should convert the first unit here. Well, at that first unit, we can see that the benefit of it being soybean plantation is somewhere up there, just under 18,000. But the benefit of it being left as forest is 15,000. So in other words, that first unit, the benefit of soybean plantations outweighs the benefit of keeping it as forest. So you know what, we're going to go ahead and do that. We're going to convert it to soybean. And we keep asking ourselves that question as we go along per square mile, until finally we get to this point where the demand curve of forest and the demand curve of soybean use meet. Or in other words, the benefit at that particular quantity is the same whether we leave it as forest or turn it to soybean. By this logic, any quantity past that, leaving that each square mile as forest has a greater benefit than converting it to soybean. That's simply because from this point onwards, the soybean demand function or demand curve is lower than the forest demand curve. So that's what we're doing. We're trying to find this Q. We can put it there and say, hey, there it is, but we need a value for it. And we're going to use our soybean demand function to do that. Remember what we can do here? We can plug in a value for Q, which will give me a P. Or I can plug in a value for P, which will give me a Q. And that's what we're going to do. We know the price at this quantity, it's 15,000. How do we know that? Because this curve here is always at 15, and that's where this one crosses. So, 15,000, the price, equals 18,000 minus 10Q. That's just the demand function. We can move some of these things around. I'm going to take the 15 grand over to this side, in which case we turn it into a negative. I'm going to take the 10Q over to this side, in which case we turn it into a positive. 10Q equals 18,000 minus 15,000, or in other words, 10Q equals 3,000. I get rid of this 10 at the front of 10Q by dividing it by 10, and we have to do the same to the other side. So we end up with Q equals 3,000. The quantity of forest land I should convert into soybean land is 300. Sorry, I can't remember if I made a mistake there, if I misspoke. We have 10Q equals 3,000. We want to get rid of that 10, so we divide this term by 10. But we have to divide this term by 10 as well. So that removes that 10. We end up with just Q, and the 3,000 is converted into 300. So our quantity is 300. So this quantity here is 300 square miles. That is the amount of land that we should convert from forest use into soybean use.